Anyway, to get back to the star, it's all held together by gravity, and it's got a nuclear fuel, which we haven't been talking about, that is burning up the hydrogen and generating energy, which keeps things going. And after a while, it would use the fuel up. People began to think about what would happen then. And it would be possible to just be gas sort of hanging around, held together by gravity, but quiet. But another possibility was to think, if I push the stuff together closer, the gravity is stronger. Would it hold together? Well, if you push a little bit together, the pressure increases. When you push gas together, there are more atoms and they pound harder, so the pressure's higher, but the gravity's stronger. And it turns out the pressure wins, so it would just come out again. If you push a star in like that, it oscillates. And there are some stars that are oscillating and vibrating and so on, but it turns out if you keep on analyzing it and you push it together very far into the incredible concentration that the whole mass of the sun is down to the size of the Earth or smaller, then it turns out all the nuclear matter, all the nuclei of the atoms are all stuck next to each other tight. The electrons are, the spaces where the electrons are, is all squashed out, and it comes out that when you get to that far, the gravity's strong enough, has overpowered the pressure again. Even though the pressure's got to be enormous, the gravity's got to be even more enormous, and the thing will stay steady at a different size and be nothing but a neutron's nuclear matter, nothing solid nuclear matter. And this is a possibility was worked out by Oppenheimer and Volkoff, and it's called a neutron star. And people waited to see if there were any such neutron stars for years, until recently they found these strange pulsars which emit flashes of radio waves, and later they found light, which can go 30 times a second, for instance, the fastest ones, or maybe 10 times a second, or 1 a second. And at first, that's very mysterious. You're used to stars being big and slow, and how can anything in a star move in a 30th of a second? Well, these things are very small neutron stars, and they're spinning very fast. And there's some, for reasons not yet understood, they're emitting a beam of radio waves, like a searchlight in an airport or something. Those things that go around, boop, 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 so we get the flashes, tick, 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 that fast. To imagine a star the mass of the sun doing something, turning so fast as 30 times a second is another one of these big number, hard to conceive imaginary things, okay? And the whole idea that there could be a star of such enormous density that a teaspoon would weigh so much that of the matter that if you put it down on the Earth's surface, it's so heavy it'll just plow right through to the center of the Earth, and things like that. It took a lot of imagination. It comes out of the mathematics and the analysis and all this that helps you to make sure you're not making a mistake. And it turns out that such a star was possible, and it turned out later, in fact, they do exist. And that's a good example of how imagination is a useful thing and produces a guessing ahead of time and how we make advances by using it. And besides just the very difficult thing of imagining all the things that might be up there to explain the things we see. In the case of astronomy, we have a large number of things that we see that we are not yet quite clearly got the imagination to see what it is that's producing it. Quasars are very powerful sources of light and radio waves for very great distances. We can see them because they're so bright. And the exact cause of their sources is only gradually being recently understood in terms of another nutty concept of imagination, the black hole, which is something that comes from following the logic of the gravity theory of Einstein to its ultimate, working out the consequences in crazy circumstances. Suppose you had an amount of matter so great that the gravity force is so much that even light trying to get out falls back. Nothing can go faster than light, and nothing could escape. You couldn't see it. How would you get there? If you had a lot of matter to start with, it could fall together and get into this condition that no longer could the light come out. And so you would have this thing which would continue to attract things to it. Things would go in and nothing would come out. That's called a black hole. And you say, well, how can a black hole, which is absorbing everything, make all this energy that we see? Is that an explanation of the quasar? Actually, it may well be, because if the things are falling in don't go plunk in, but go around, falling in by swirling, then as they fall in and irregularly and so forth, and in the fast motions that it produces, they go down this whirlpool, they generate a lot of energy and friction and so forth, and different kinds of effects, magnetic and electric effects, that could make the jets of matter that come out of the quasar and the radio galaxies in ways that are not really understood. We don't have a real picture of why there are jets of radio waves and so matter emitting radio waves in galaxies. There are galaxies in which great jets have come out of big clouds of matter on each side, which are emitting radio waves. So there's some kind of a source in there that sort of gets wound up and shoots these jets of material out with tremendous energy, and it's guessed that maybe that's a black hole somehow or other. And the somehow or other is the challenge of imagination, which has not yet been answered by anybody with any great confidence.